So I'm on the last of the video tutorials using transition metals in ionic compounds. If you need to, go back and watch the crisscross method of writing ionic formulas as a prequel, I guess, to this video. So when you're dealing with transition metals, remember those are the D block elements on the periodic table, in addition to some of the elements that are underneath the metalloids. So we're talking tin, lead, and then the D block elements. But they can change their charge because of their electron arrangement. So we have to be specific in the name and the formula according to which cation we are referring to. So in order to do that, we have to use a Roman numeral to indicate the charge on the cation when we're naming the compound. Or if we're given the name, in that name, the Roman numeral then refers to the charge on the cation. Now, when you're writing the formula, you're still going to use the crisscross method. So that makes it fairly easy to write the formulas for transition metal ionic compounds. There are more exceptions to not needing a Roman numeral, but the three most common ones are silver, which always stays at a +1 charge, zinc, that always stays at a +2 charge, and cadmium, that always stays at a +2 charge. So if you see silver, zinc, or cadmium in a chemical formula or in a name, it's okay that it does not have a Roman numeral. It does not need one, so you shouldn't write it with one. But I've got about 4 examples here of names that do contain Roman numerals, and we'll write the formulas for these, and then we'll talk about how to, given the formula, go back and write the name. But it's still the same method as writing the formulas for binary and ternary ionic compounds. And you can have Roman numeral transition element compounds that are binary, like this first one, manganese 3 chloride. Or you can have Roman numeral compounds that are ternary, which means they contain a polyatomic. How do we know? Because this ends in 8, okay, not "ide." So if we were going to do these for the chemical formula, the charge on manganese here is +3. The Roman numeral is always positive, and it always indicates the charge, not the subscript, on the metal cation. So the formula for manganese is Mn +3, and then chloride is Cl, and based on the periodic table, I know Cl has a -1 charge. So without actually drawing the arrows for the crisscross method, remember I'm going to move the +3 over and across to become the subscript on the chloride. So my final formula is MnCl3, because the -1, the 1 moves over and becomes the subscript on the Mn. If I look at gold 2 bromide, this tells me that the charge on gold is a +2. And then I'm going to look up bromide on the periodic table, or you may already have it memorized now that bromide is a -1 charge. So once again, crisscross your charges to make your subscripts. So your final formula is going to be AuBr2. If I look at copper 1 sulfate, copper 1 is Cu+1, and then sulfate, remember it ends in 8, so you have to think, is it SO4, SO3, SO2, what is it? So hopefully you have those memorized. Sulfate is SO4, -2. So when I crisscross these charges to make my subscripts, then the copper is going to get the 2, and SO4 gets the understood 1. I don't need any parentheses there. And then lead 4, that's a Roman numeral 4. I don't know if you can tell it by my handwriting, but that's lead 4 oxide. Well, this is lead, Pb, with a +4 charge. Oxide is O with a -2. You find that out from the periodic table. Hopefully you're thinking one step ahead of me at this point, and you already know how to write this formula. But if I'm crisscrossing my numbers, the Pb then gets the 2, and the O gets a 4. But that's not the final answer, is it? So remember, anytime that you're writing formulas for ionic substances, they have to be in lowest terms. So the 2 and the 4 can be reduced. So your final formula is PbO2, which makes it a little bit more difficult when you are writing the names for the compounds, because you're not always sure that your subscripts are exactly how they appear on paper. Because if they've been reduced, your subscripts are going to give you a different charge on your cation. So naming, remember, requires uncrossing the subscripts. Or the better way to do this is to do mental math to discover your cation charge. Sometimes it works if both elements have a subscript that you can just uncross them. So if I were going to look at this, I know I have chromium, and I know I'm going to write oxygen as oxide. So I can at least go to that trouble. I know chromium is a transition metal, so I'm going to have to put something in parentheses there in terms of a Roman numeral. But because both of these have subscripts, I can just uncross that 3. I don't necessarily have to uncross the 2. That's just to double check. Just make sure that when you do uncross that, that meant that the oxygen had a -2 charge. But if I do uncross this, this means that my chromium had a +3 charge. So that's going to be chromium 3 oxide. What do you do, though, if you don't have any subscripts? It doesn't necessarily mean that I had a +1 and -1. It could mean that I have a reduced situation on my hands. So this is what I mean by mental math. You need to look at what your charge on your anion started out to be. So go back to your periodic table and look up oxide. What's the charge on oxide? If you're looking at your periodic table, the charge on oxide was -2. Well, if I have one oxide with a -2 charge, what would your copper have to be to cancel it out? So in this case, this is copper, Roman numeral 2, oxide, not copper 1. So that's where mental math comes in handy. Same thing here. If I have a subscript on the second element, but not on the first, I have to really think about what my charge would be on my anion. In this situation, nitrite is a -1 charge, and I needed 2 -1s. That's what the parentheses 2 there means. So if I have a total charge of -2, what did the charge on the lead have to be? Equal and opposite. So this would be lead, Roman numeral 2, nitrite. Once again, you could kind of get it from uncrossing your charge, but you might not get the right answer there. The only reason that it does work is because ordinarily nitrite is a -1 charge. So that meant that the understood 1 here was fine. On the last one, NiCl2, once again, if you uncross the chloride, you're just going to be lucky that the charge works. because chloride normally has a -1 charge by itself. So once again, if you're uncrossing, about the only way that you're going to be safe with that is if both of your elements have a subscript. If you only have one subscript on one element and not the other, you're going to have to do the mental math part and think about the total number of anion charge versus the total number of cation charge. So if I have two -1s here, that means I had a total of -2 charge. So what did your nickel have to be? It had to be a +2. So nickel 2 chloride. Guys, don't forget that we do have a test tomorrow. That's Monday, January the 30th, in all of the honors and general chemistry classes. On the test, you can use the periodic table and you can use your naming wheel that we made in class on Friday. Come see me tomorrow at the beginning of the period if you have any questions about anything. But hopefully these videos have helped you. At least you can, pause it, rewind it, watch it again. Thanks, and have a great rest of your weekend, and I will see you bright and early tomorrow.